Hello students, in this video we are going to learn chapter number 5 probability distributions from this book 7th edition Statistics for Management by Levin and Rubin. So what is probability distribution? In fact, we can think of a probability distribution as a theoretical frequency distribution, right? So we have distribution generated from a random variable. So what is a random variable? So random variable is a result of a random experiment. There are two types of random variables: discrete random variable and continuous random variable. So this is an example they have given you. For example, in a breast cancer screening clinic, there is a record being kept of how many women will be screened on any one day. So you have this record. For example, number screen 100 on one day, 101 on the 2 days, 102 on 3 days. So this is your variable, which is your random variable, and it is discrete because it is taking values from 100 to 101, 102 like that, and this is the frequency. And when we plot this, when we convert these frequencies, total there are 100 observations. So when you divide this by 100, you get probabilities. So this is the probability distribution data, and when you plot it, you will get a discrete probability distribution, which is this. This is your discrete probability distribution. And we have continuous probability distributions also, which result from a continuous random variable. There are two types of probability distributions, discrete probability distributions, which are well known. First is the binomial distribution, which is actually named after Swiss mathematician Jacob Bernoulli, and hence it is also called as Bernoulli process, although this is not covered here. Then we have Poisson distribution, which is also a discrete probability distribution. This is named after Simon Denis Poisson, a French mathematician, right? Queuing model or queuing theory is an application of Poisson distribution. It will be covered in a different video on queuing theory later on. Now, the normal distribution is the distribution of a continuous random variable, right? And normal distribution is what we are going to study in this particular video. Mathematician Carl Gauss is one of the major contributor in this, and hence normal probability distribution is often called as Gaussian distribution, right? So this is how it looks like. In normal probability distribution, you will have a mean median mode coinciding at the center, and when you just fold this page along this line, then these two sides will exactly match each other. So the total area under this curve, if you consider 100%, right, then 50% will be on this side and 50% will be on this side. In this distribution, the left hand tail as well as right hand tail will extend parallel to, or it will be moving towards x-axis, but it will never reach x-axis, right? So this is, you can read the characteristics of probability distributions. It has a single peak and all that, so you can read this for better understanding. Now when we talk of probability distribution, we can have different things. For example, this is an example where you have the mean of probability distribution common. For all the three distributions, it is 50, but distribution, this one, the one has a standard deviation of 1, the middle one has a standard deviation of 5, the flat one has a standard deviation of 10. So although all the three are normal probability distributions, they look different, right? and each one has a different standard of deviation. This is an example where all the three distributions have different means. First one has a mean of 15, second one has a mean of 25, third one has a mean of 35, but all the three have same standard deviation of 5. Here is an example of different means as well as different standard deviations. So the areas under the probability curve is, as I mentioned to you earlier, it is 100, and when we consider it in the probability, you can consider it as to be 1. So for the normal probability distribution, if you consider limit from on either side of the mean as sigma, so this is sigma plus mu plus sigma, this is mu minus sigma, here is your mean mu, then that will contain 68% of the area, and on both sides you will have 16% approximately outside. When you go for 2 sigma on either side of the mean, it will contain 95.5% of the area, and for 99.7% of the area will be contained between plus or minus 3 sigma. Now we have seen different normal distributions with different means and different standard deviations. So we can use a standardized score which is given by Z. So if you can see, is standardizing a normal random variable Z, which is x minus mu upon sigma, and when you use Z instead of x along this x-axis, you will get something like this. So you have this x-axis x values and corresponding z values. So z value will be 0 at the center, because here x and mu are same, so the numerator will become 0. So this will be plus 1, this will be minus 1, this will be plus 2, this will be minus 2. So these are the z values, and when we do this, we can read the areas using a standard normal distribution curve and table which is available in the appendix. For example, if the z value is 2.24, then you will see 2 here on this left 2 and 2.4. So if you see here, this is z 2.24. So 2.2, you have to go to 2.2 and 4, this one. So the answer is for 2.2 and 4, 0.4875. So the area under the curve is 0.4875. If you are considering between z plus 2.424 and minus 2.24, then the area will be double of this, right? So this is how we read the area under the curve using this normal table. We will be taking one example which will clarify the different uses of this normal distribution in solving the problems. So in our next video, we will be looking at that example where we will learn more about it. Thank you.